For question B, we are asked to find the coordinates of n, and we're given that the tangents at the point P, the tangent at the point P and Q meet at the point N. So we have the equation of the tangent at P. Now we don't even need to work out the equation of the tangent at Q because it's exactly the same, but where I see the letter P, okay, I have the letter Q instead. So I can straight away write down the equation of the tangent at Q as equal to QY is equal to X plus AQ squared. So I'm going to pause there. I've already done the hard work to work out the tangent at P. I have exactly the same situation, but with the letter Q instead. So I already have an equation of the tangent at Q. They meet at the point N, so I have to find the coordinates of N. Now, like any two straight lines, where they meet, it's the solution of the simultaneous equation. So, if you like, equation 1 is, I'm going to rearrange it and make y the subject. So y is equal to x plus AP squared all over P. And equation 2, y is equal to exactly the same thing, but with the letter Q. So now I have y as the subject of both equations. I can equate the two. So my next line will be x plus AP squared all over P is equal to x plus AQ squared all over Q. I'm trying to find x in terms of AP and Q, where I'm just going to emphasize this point one more time. This looks like a complicated algebraic expression. However, if we bear in mind that these are simply constants, I'm just going to circle constants, and getting the coordinate of x is simply GCSE algebraic manipulation. We can multiply both sides by P and multiply both sides by Q. And again, when we're at home, if this is too fast for you, we can slow it right down and do the algebra ourselves first. That's what I'd recommend. Pause the video at this stage, have a go at the algebra. You're left with Q bracket x plus AP squared is equal to P bracket x plus AQ squared. Okay, they're all very straightforward. And multiply out the brackets. Since P is first in the alphabet, I'm going to take it to the P side, okay? Just because it doesn't really matter, but if I take the Q to that side, I mean, from here we should all, I could ask a year 10 student to do this, yeah? We could rearrange it to find x, okay? So I'm going to do this all in one go. Again, when we go home, we can watch this again. But x is equal to AQP squared minus APQ squared all over P minus Q. Okay, now I can simplify it, and if I factor out APQ on top, APQ, I'm left with P minus Q all over P minus Q. And this is obviously APQ. just to be clear, because that cancels with that. Okay, so now that we have the x coordinates of the point N, we can substitute x is equal to APQ back into either the first or the second equation. I will simply choose the first equation and sub in x as APQ. So therefore y is equal to APQ plus P squared all over P. That simplifies to AQ plus A plus P. By now, you should have spotted the deliberate mistake. And it's actually AP squared here, not just P squared, AP squared. So when I divide through by P, I have AP plus AQ, or AQ plus AP. So that's A bracket P plus Q. So to complete my answer, N has the coordinate APQ, comma, A bracket P plus Q. And that is the coordinate of N. So part C says that given further that N lies on the line with equation y equals 4a, find P in terms of Q. Well, we know the y coordinate already. The y coordinate y is equal to A bracket P plus Q. And we are given that it lies on the line y equals 4a. In other words, we can substitute y with 4a. So 4a is equal to A bracket P plus Q. If I divide both sides by A, I get 4 is equal to P plus Q. And I want to find P in terms of Q, and therefore P in terms of Q means P is equal to 4 minus Q.